Online. Okay, great. And thank you very much. And I really enjoyed the three previous speakers' talks. And so I think this is giving a very nice overview about the education and research opportunities at different institutes and different countries. I guess now we are switching back to Europe. So, in my next 30 minutes, I would like to give you a brief overview about integrated circuit designs and the research education in Switzerland. So perhaps a little bit different from the previous three talks, and instead of diving down to the details of certain, let's say, one or two research topics, rather I would like to focus more on the as an introduction talk, and to show you what is the general research landscapes, who are the major players and in terms of organizations for IC designs, for IC design research in Switzerland. And in general, how we are getting our funding and how do we support our research. And at a very high level, I would like to give you an overview about the research topics we are interested in, not only for my group, but also, as a matter of fact, here I have materials for 8 faculty members and across 3 different institutes and in Switzerland. I hope this will give you a good overview about our activities and here. By the way, I also would like to make a disclaimer that as a matter of fact, I moved to Switzerland and a little bit less than 3 years ago from the United States. So I wouldn't say how Swiss I am, or let's say how European I am. But however, over the past 2-3 years, I did get a very good experience about understanding and collaborating with different organizations and universities and companies in Europe in terms of IC design research and education. So therefore, I hope the information I'm providing in my talk and you will find things useful. All right, so let's move on. Okay, so well, first of all, I would like to say hello or Grüezi from Switzerland, because we are in the German-speaking part of the Switzerland. This is where Zurich is. Well, I'm very glad that Professor Fager presented the research activities in Chalmers University and also from Sweden. So people know that Switzerland and Sweden are not the same country, and often this could be confused. So where is Switzerland? It's really in the middle of Europe. So we have France to the west, and Italy to the south, and Austria basically to the east, and also Germany to the north. And here I'm showing you several interesting, beautiful pictures, I would say, and because I believe most of the audience and here are students and looking for education and research opportunities. So therefore, I would like to first show you what do we do and outside the labs, outside the schools. And this is the picture and showing a village called the Zermatt, and it's an iconic place and with a pretty famous and mountain peak called the Matterhorn in Switzerland. And this is a picture of a pretty famous valley and called the Lautenbrunnen, and in the Interlaken area in the middle of Switzerland, and it is famous for its 72 and the waterfalls and across this mountain valley. And this is a picture actually of 2 of my kids, my son and my daughter. And this is the time when we took this picture 2 years ago when we were having a summer vacation in one of the villages, and a small village called the Muren in the southern part of the Swiss Alps. So we really enjoy the natural beauty here and offered by Switzerland. So here are the 3, and I would like to say, major cities in Switzerland. Of course, there are others, but this is the Zurich, and this is the view of this is the Lake of Limmat, the river, and connecting to the Lake of Zurich. And Zurich is the place where ETH Zurich is located at. And this is the city called Lausanne, and this is where it's a very beautiful city right next to Lake Geneva. And this is where the famous university EPFL is located. And this is a city called Geneva, and of course basically at the other end of the Lake of Geneva. And this is where the very popular Neuron X Center and a variety of research facilities, institute like CERN are located at. Okay, so this is the outline of my talk. And first of all, as I said, I want to give you an overview, and I would like to present and the Swiss integrated circuit research landscape and also the heritage, the history of it. And next, I want to show what are the funding opportunities and for Swiss institutes on IC research. And then finally, I would like to give you several examples of our IC research topics and the projects and at 3 different Swiss institutes. All right, so when we are talking about IC research landscape, and here I think on this slide, I'm trying to show the major players here. And we have ETH Zurich and EPFL. These are the 2 sister universities, both under the umbrella of ETH, right? Swiss Federal Institute of Technology in Zurich and in Lausanne. And we also have our Swiss Research Institute, it's called the CSEM. This is a little bit like Swiss version of IMEC. We can say that size is smaller, but it has a lot more focus on all the microelectronics and the technologies. At the same time, we also have partner institutes like University of Zurich, which is right next door to ETH Zurich, and they have really awesome hospitals and medical programs. So all the biomedical research, and we are doing collaboration with the University of Zurich. At the same time, there are other companies and research institutes are playing major role in the IC designs and the research. For example, the Paul Schiller Institute, and they offer novel devices and materials and also devices under the extreme conditions. And we have IBM Zurich, and which is just across the lake from ETH Zurich and across the lake of Zurich. So they are working on quantum computing, cryogenic electronics, and bioelectronics with microfluidics, and the new computer architectures in memory computing, and so on and so forth. And we of course also have the CERN and the research and institute, which is essentially in between of Switzerland and France. And this is the place where we see this application and research on electronics for high energy physics and particle physics, and with radiation hardened requirements. So a lot of players here. So at the same time, okay, so when we are talking about Swiss IC, and I think it makes sense for me to talk about the history and the Swiss IC heritage. So maybe perhaps it's basically we look at the history of CSEM, this will give us a good understanding of the entire Swiss IC and the history. So back in 1939, and this institute, this lab called LSRH, and the Swiss Lab for Watchmaking Research was established. And then in 1962, and the center called the Center of Electronic Horology is established in Switzerland. Okay, and in 1967, this is the time when the first quartz and the wristwatch was invented in Switzerland. And in 1978, and this is the time when it's called Swiss Foundation for Research in Microtechnology, FSRM, was established. And later, in 1984, these 3 institutes are merged together to form this new research institute called the CSEM. So at this moment, the CSEM as a Swiss National Institute has overall about 600 employees and 100 million of turnover rate and Swiss francs, and has been the home for more than 50 spin-offs since 1984. And as you can see that, well, if we look at the Swiss IC heritage and focuses, it has a lot of emphasis on low power and the low power electronics, energy efficiency. This is because the Swiss ICs were initially started as to support the high performance and the Swiss watch industry, Swiss watchmaking. But of course, things are very different right now, and presently the IC research has been expanded way above this boundary, and now we are looking at high performance wireless, which I'll talk about, electronics and the photonics and the mixed signals and digital circuits, digital systems, and microprocessors, like a RISC-V microprocessors, and also bioelectronics for both implantable and also benchtop and the devices. Well, if we look at the Switzerland overall, and it has been very proud of being a global powerhouse for innovation and talents. If we look at the United Nations Development Program, and they proposed this Human Development Index, which captures the health and let's say and the knowledge and the quality of life and overall all these indexes, you can see that Switzerland has been top on the list among all the countries surveyed by the UN, I think in the past 13 years. At the same, we can also look at this on the World Intellectual Property Organization, WIPO, and they propose this Global Innovation Index, and Switzerland typically always top 1 or top 2, and neck to neck with Sweden, of course, and the United States. Yeah. So as a result, in Switzerland, and as a small country, it attracts a lot of capitals, and as well as the top researchers from all over the world. When we are talking about the research and education, we have to look at the universities. So in Switzerland, Switzerland is also proud of offering two global top universities. One is ETH Zurich, the other one is EPFL. So I'm not a big believer of these university rankings, but sometimes when students are deciding which school they want to join, they do look at the ranking. So and we are doing pretty well on the ranking as well. In the recent QS ranking 2024, if we look at the engineering technology subject in general, and ETH Zurich is ranked number 6, and our sister university EPFL ranked number 10 in the world. If we look at the electrical and electronic engineering in particular, probably more relevant with the topic and we are talking about here today, and ETH is ranked number 5, and our sister college university EPFL is ranked number 7. At the same time, and so we are offering a very high quality education and research opportunities. At the same time, we are treating our students and also postdoc researchers, research scientists, scientific staff very well as well. So you can see that, considering the cost of the living in Switzerland, and we are paying and our students, staff, and postdoc researchers in a very generous way. So typically EE students and computer science students are being paid at rate number 4 and number 5 for ETH Zurich. I don't know our sister university EPFL how their salary level, but I believe it should be very similar in Lausanne. And our postdoc and the researchers and scientific assistants are being paid and also at a very high salary. And these are the Swiss francs. So if you convert to US dollars, you need to 10, multiply like say 1.1. Yeah. So basically, we want to make sure that everyone will be able to live a comfortable life and during their study and the research here in Switzerland, so that they can, on one hand, enjoy the life, on the other hand, really focus on the research and on all the technologies. Okay, so now let's look at what are the funding opportunities that we are typically pursuing at the Swiss Institute on IC research. So in Switzerland, the major funding body is a government organization called the Swiss State Secretary for Education, Research, and Innovation, in short called SERI. So SERI has a pretty sizable budget, and in the next 3-4 years, I think the SERI entire budget is about 29.2 billion, and for the entire research budget. But please consider that Switzerland is a small country. There are only around I think 8.5 million to 9 million and population in Switzerland. So if you normalize with this the total research budget from SERI, and this is actually per capita is very large and very high. And as one of the research arm under the SERI, and it's called the Swiss National Science Foundation. This is perhaps an equivalent part of the US National Science Foundation. So in 2023, and there are Swiss francs 961 million and for the research projects, and by Swiss National Science Foundation, and additional 235 million that in that year as a bridging funding to support Swiss researchers to participate in the EU Horizon, variety of EU Horizon programs, which I'll talk about later. And total at the end of 2023, there are 5,500 NSF funded research projects with combined together 21,000 researchers, and currently ongoing on the way. So within the Swiss National Science Foundation program, there are multiple funding mechanisms, and we are often applying for. One is the standard project funding. It can support one PI all the way to 3 PIs, and with each PI and funding about the, let's say, typically up to 800,000 Swiss francs, and for over a 3-year of research period. And there's this bridge funding, and that encourages the collaboration between university and the startup company, and to translate the research and from the lab and to the actual possible products to impact the society. And there's also this dedicated research equipment and called R-Equip program by the Swiss National Science Foundation, and my lab actually benefit a lot from this R-Equip program, and to help us and keep upgrading our research facilities. And also there's a lot of strong emphasis of collaboration between Switzerland and also international universities and organizations. For example, this SNSF and the collaboration with US NSF program, and it is sponsored by the Swiss National Science Foundation. So my team also has one program under this umbrella in collaboration with UC Berkeley and in the United States. Okay, so then there's another branch of the funding opportunities in Switzerland. It's the organization is called InnoSwiss. The focus is a little bit different. Here, the focus is to promote the innovation and support Swiss SMEs, so small, medium-sized enterprises, as well as startups, and together with their collaborations with Swiss academia, essentially universities. So InnoSwiss also offers a very sizable funding, and in 2023, and the total budget was like 490 million, and including the Swiss accelerators and mechanism for startups. Of course, being in Europe, and Switzerland is actually not an EU member, and is actually called a non-associated member, but we still have the possibility to participate in a variety of EU programs. For example, the famous Horizon Europe, and this is the EU's and the key funding program and for research and innovations, and with a total budget of 95.5 billion over 7 years. And there's another program called the European Research Council, ERC, and this is a typical single PI program, and with a starting grant, consolidator grant, advanced grant, and also like synergy grants for multi-PI programs. And there's also this Marie Curie and a fellowship program for both doctoral students as well as postdoc trainings. So I think Professor Farger had already given an excellent overview of these programs. So I don't want to repeat the information, but at Switzerland, for Swiss universities, we are still eligible to participate in all these programs. Okay, so in Switzerland and in particular, I think starting from this year, we have this Swiss Chips Initiative. It's led by Professor Christoph Studer at ETH. It's a funding for 3 organizations: ETH Zurich and CSEM and EPFL. So I would like to give you a brief introduction of this Swiss Chips Act. So, well, first of all, we can see that almost all the major countries or let's say economic and entities or regions that are particularly leading at the leading edge of the semiconductors are all giving out all kinds of government subsidiaries or programs or stimulation programs, and called CHIPS Act, right? And the focus of these CHIPS Acts is really to enhance the production designs, and also with an increasing focus on their own digital sovereignty. Right? This is important, and within Switzerland, and this is also viewed as a very important strategic investment. And at the same time, we also need to realize that this increasing geopolitical tensions and restrictions, and at least limitations. We should not be naive about that, and we at least should not be, pretend to be naive about that, right? And at the same time, we know that all these microelectronics chip designs are just getting rapidly evolving and becoming more and more complex than ever. So as a result, and the Swiss government decided to launch this Swiss Chips initiative. And so in a nutshell, it is the funding and directly from the government to support the three and the research organization, education organizations, ETH Zurich, EPFL, and the CSEM. So it is led by ETH as the leading house, and my colleague, Professor Christoph Studer, is the director or the head of this initiative. It's as a first phase one, it's a 3-year transitional measure. So with a combined and direct investment from the government of 26 million and from SERI, and in conjunction and with a 7.8 million in kind and investment from all these three organizations, and I think equally divided. So the goal is to really boost the resources and to support the infrastructure and the talent and a variety of R&D projects on chip designs in Switzerland. So many of these measures are really close to the development with Europe. The goal is to eventually help us to reintegrate Switzerland back to the EU family, or before that, at least we'll have ample of resources to continue our research. So here is the summary of the work packages within the Swiss Chips initiative. And you can see that there are multiple very hot topics are all here, right? Computation and computing systems on chips, computing architectures, 6G wireless communication, Swiss electronics and photonics, and SoCs for IoT devices, edge chips for edge AI, and this is like low power and the smart AIs, and the biomedical circuits and systems, as well as the device and the sensors. So these technical work packages are very much in line with the major EU initiatives, programs, and the projects. But perhaps the difference is that the Swiss Chips Act will focus a lot more on the IC designs and the innovations itself. Yeah. There also, of course, and the important dissemination and outreach and activities in the Swiss Chips Act. So, overall, we expect over this 3-year time span that there will be 180 publications and 48 prototypes and different in the technical events, social events, and the workshops. And hopefully we are aiming at graduating 40 or more than 40 and PhD students, and sponsored by this program. Okay, so with all these some funding support, I think that most of the research groups in Switzerland are quite well equipped. I don't have the pictures or information from other research groups, but here at least I can share what we have in my group called ETH Ideas Research Group. And here is just essentially a snapshot about our RF and military research facilities. And for example, we have a wide access to a variety of foundry processes, and with STMicro, Global Foundries, and Dresden, Global Foundry US, you can see all the advanced silicon germanium and CMOS SOI technology we all have. And we are also working closely with TSMC in Taiwan, 16 nanometer FinFET, and Intel, and 16 nanometer FinFET as well. And we are also collaborating with the industry partners like Mitsubishi Japan, and gaining access to their GaN and gas technologies. At the same time, and we have regarding our facilities, right? And my group, we have, for example, two 67 gigahertz 4-channel PNAX network analyzers, and 2 AWGs and 4 channels, and each with 4-channel, and each channel has like 65 gigasample per second per channel, and 2 Keysight and UXR 4-channel real-time oscilloscopes, and up to 70 gigahertz real-time sampling and bandwidth, and 4 MPI probe stations working parallel. And we also have our own and packaging facilities all the way up to deep band. Yeah. Okay. So next, and I think, perhaps I'm running a little bit short on my time. So I want to give you a very also brief and a snapshot about the research activities we have. So let's start from ETH, right? This is my colleague and the professor and Luca Benini, and he's an IEEE fellow and ACM fellow, and also a member of academia and Europea. And his research group has won many research awards, and his focus is mainly on the digital VLSI, multi-core SoCs, and machine learning hardware. So if you are interested in the computer architectures and RISC-V microprocessors, accelerators, and let's say neural processor units and all these things, please contact Professor Luca Benini. Yeah. This is a kind of a summary about my research activities. And as I said before, joining ETH Zurich, and I was actually a professor assistant and then tenured associate professor at the EC of Georgia Tech and the US for over 10 years. And so I have, my group has been pretty active in the research. So I really thank my members and the students and the postdocs for their and the contributions of our research. And so my group, we focus a lot on the integrated circuit designs and systems for wireless communication, sensing, and bioelectronics. So presently I have 15 PhD students, 7 postdocs, research scientists with about 2.5 to 3 million Swiss francs per year of operation budget. We are also growing our group, and later this year, in the middle of next year, and we'll have another 5 new PhD students and joining my research group. So our research project-wise, we have this project on beyond 5G, 6G, and wideband energy efficient power amplifiers and transmitters. This has been sponsored by EU CHIPS and the JU. Joint undertaking and a SHIFT project and Mitsubishi Japan, and previously US DARPA and the Air Force Research Lab, and also Army Research Lab. Here, the goal is we want to investigate new circuit topologies to really overcome the solid state power generation limits, bandwidth, efficiency, linearities, and so on and so forth. So other research projects right now we are also working on, and large scale intelligent arrays, and this is here we zooming onto phase arrays. And for 6G and SATCOM and the radar applications, this is sponsored by the Horizon Europe and the 6G reference project, and this joint SNSF and US NSF project together with UC Berkeley and also Swiss CHIPS Act. At the same time, my group, we are also working on the multimodal and joint molecular and cellular sensing array in CMOS, and for a drug screening applications, point of care devices, and DNA processing, and so on and so forth. This has been sponsored by Swiss National Science Foundation and the Swiss CHIPS Act. Right. My colleague in the Professor Ulrich Leuthold, and also the head of our department, and his research is focusing on the different areas of optical and wireless communications, and integrated optics, and the plasmonics and the photonics. So therefore, and you can see that there's a very nice complementary and synergy between our research groups. So he's also working on the millimeter wave terahertz devices and the system level testings. So if you're interested in the integrated photonics, high-speed photonics, electronics co-integration, you should talk to Ulrich and Professor Leuthold. And one of the demonstration they have recently built based on the EU project Vertigo is on this terabit per second satellite link, and which overcomes the bandwidth limits of current and the LEOs and the Earth and the SATCOM link. The paper has been published and pretty recently at this Light Science and Application and the journal. I think they also have a pretty comprehensive portfolio on different parts of the communications. Okay, hello?
Can you hear me?
Yeah, I will wrap up very soon. Yeah, I will wrap up.
Thank you.
Yeah, thank you. Yeah. Okay, from modulators to photodiodes to the plasmonic antennas, and this is the research portfolio for my colleague and Professor Christoph Studer. And he is an associate professor and with tenure at ETH Zurich. And before that, he was an assistant and associate professor at Cornell University and Cornell Tech. And he is focusing more on the algorithms and the digital parts of the communication chain, and also sensing and the applications. Right, his research is mainly sponsored by the Swiss National Science Foundation, and also the CHIST and the ERA and the grants. And this is one of the topic is on this all digital transceivers for millimeter wave multi antenna systems. Another research and the topic from his group is this all digital in-memory processing for digital beamforming, fast energy efficient digital beamforming. So you can see that his research and my research and Ulrich's research, we really like go hand in hand with each other to build the entire system. And this research has been sponsored by the Swiss National Science Foundation and the Swiss Army, Armor Swiss. This is the research portfolio from my colleague and Professor Taekwon Jung, and he is currently an assistant professor at ETH Zurich. Before that, he was a senior design engineer at the Samsung and Electronics. And his area is focused a lot more on analog mixed signal circuits and miniaturized IoT devices, PLLs, and power efficient and power management circuits. And their research has been sponsored by the Swiss National Science Foundation starting grants. This is the ultra low power ICs and the next generation IoTs. And they are, and another line of their research is on this energy efficient analog and mixed signal circuits, sponsored by Swiss National Science Foundation, NIH, InnoSwiss, and ERC grants. Right? Very many publications at and high profile conference and journals. And my colleague and Professor Andy Berg and from EPFL. And he is working on this wireless communication algorithm systems, basically the joint design of circuit systems. And he also founded the 2 startup companies in this cross layer of research of these areas. So one of the topic of his group is this next generation channel coding and decoders for 6G. This is, I believe, sponsored by the Swiss Chips Act. And they are also working on this approximate computing and with unreliable silicon and devices, and also this very high energy density and very high density and embedded memory and the systems. Right? What they can achieve like 50% better in density than the SRAMs, existing SRAM. So if you are interested in this area, please contact Professor Berg. Colleague, and I think this is the last the faculty profile I want to present today. Colleague and Masha and Shawaran and from and EPFL, and she is currently an assistant professor at EPFL and the NeuronX. And her area is mainly on the IC design, machine learning, and neurosciences, and really at the cross section of these 3 areas for biomedical applications, implantable devices, brain machine, and interfaces. Oh, I forgot there's one more person I want to emphasize. So, and Dr. Paulo Del Fabro, and he is a group leader at the CSEM and received his PhD previously from EPFL. And Paulo and my group, we have very close collaboration with each other because they are also focusing on a variety of advanced wireless communication and sensing applications like radar and narrowband comm and 6G millimeter wave from 60 gigahertz all the way to 240 gigahertz, and also precise and timekeeping. So the CSEM is as a researching institute, they often will have joint PhD programs together with ETH and the EPFL. So if you are interested in more on the industry and the PhDs or part-time PhDs, this will be a very nice option and for you. Okay, so finally, it's my great pleasure, and sorry I'm running a little bit over my time, but it's my great pleasure to present this overall profile of some of the faculty members at the Swiss Institutes in terms of IC related and research. So if you are interested in our master PhD programs, please contact us. Thank you.